machines are to be rotating type machines. Okay, those are to be get producing with respect to the rotating magnetic field. Okay, all the phases are having a displacement of 120 degree. Okay, here which is to be represented as omega t, but I am representing with respect to the theta. Okay, then all the displacement part which is happened will be get produced by the each of the phases, R phase, Y phase, B phase, proportional to that of the whatever the connection which is to be made. Okay, which will have a displacement of 120 degree each other. Then the whatever the rotating magnetic field is there. Okay, you can capable to see here whatever the displacement which is to be caused. Okay, in clockwise direction with respect to that operation, what is it to be taking place from the individual point, whatever the displacement is to be caused. Okay, because of this reason only the torque have to be developed, then it will start rotating. Okay, this is also be important. Okay, but I have drawn this with respect to the vector diagram. Then this is what the induction motor. Okay, which it is having a driving shaft. Okay, the shaft is supported by what? Rotor. Okay, this rotor itself is squirrel cage one. Then the outer covering of the machine will carry the stator slots. Stator conductor is called as stator. That is the stationary part. Then there will be a cooling fan will be present. Then stator winding will be there. Okay, which it is get connected to that of power supply from the terminal box. Okay, this is the what? The representation of the induction motor, but it is not required to draw this diagram. Okay, I have used the line diagram. Okay, that line diagram you can practice. That is more than enough. Okay, this is what the parts of the induction motor. Okay, the outer covering. Okay, then with respect to that to be get closed at the each end. Then wiring terminal, that is terminal box. Then motor frame. Then stator is having, which it is having a number of stator slots. Over that stator slots, the rotor conductor will be placed. Then which it is having a rotor. Then rotor will be get with respect to that of the rotor slots. In these rotor slots, the rotor conductors are placed. Okay, then which can be get supported by the bearing, which is connected to the end bell. Okay, these are what? The parts of the three-phase induction motor. Okay, these are the types which is not required for you, but you need to concentrate on squirrel cage. Okay, the squirrel cage induction motor is one. Okay, in which the shaft is there, then which is having the rotating part. Okay, that itself is called as rotor. On that rotor, the rotor slots are present. In that rotor slots, the rotor conductors are placed. Okay, which can be short circuited by the end ring. Okay, which are to be get connected to the system. Okay, this is the three-phase induction motor, the squirrel cage machine. Then with respect to the slip ring, okay, you can capable to see here. This is the rotating part, rotor, then which it is containing the rotor winding. Okay, then that rotor winding will be having a rotor slots, which is having a skewed rotor. Then over that shaft, the slip rings are placed. R phase, Y phase, and the B phase. Okay, that shaft will be get supported. For this, we can get connected to the power supply. Okay, which is to be shown here. R, Y, B. Okay, which are be get connected to the slip ring. Over this slip ring, the carbon braces are placed, which are get connected to the external resistance. Okay, I connected top end, but here connected resistance bottom end. Nothing to worry. Okay, the connection will be remain same. Okay, this is with respect to the what? The slip ring induction motor. Okay, then application of the slip ring and the squirrel cage induction motor. Okay, which are to be used for moderate starting torque, especially for the driving fans, blowers, water pump set, grinders, lathe machines, printing machine, drilling machines. Okay, the slip ring machines are most commonly using for the high starting torque in case of lift, hoist, elevators, cranes, then compressors. Okay, for all these are the what? The applications of the three-phase induction motor based on the types, that is the squirrel cage and the slip ring. One question paper they have asked the application of squirrel cage and the slip ring itself. Okay, for the 4 marks, so that you can concentrate on the same. Okay, it ought to be there in my notes also. Okay, then I have discussed this problem also. A 3-phase, 6-pole, 50 Hz induction motor having a slip of 1% at no load and 3% at full load. Determine the synchronous speed, no load speed, full load speed, the frequency of the rotor at standstill, frequency of the rotor at full load. Okay, these things you can concentrate. Okay, this PPT also I will upload. Okay, if you want, you can refer, but already it is there in Drive. You can go through the same. Okay, majorly you concentrate on the formula, that is NS is equal to 120 by F. Okay, is my screen is visible now? Excel sheet.
Yes, sir.
Okay. Here, most important formula related to the induction motor is synchronous speed. NS is equal to 120 F divided by P, which it is in terms of RPM. That is the revolution per unit. Frequency is, that is F is the frequency of the power supply. N is the number of poles. Then what is slip? The change in speed from synchronous to actual speed, which can be expressed in terms of synchronous speed, which itself is called as slip. Ns is the synchronous speed, N is the actual speed of the induction motor, which will also be in terms of RPM. Then whatever the actual speed of induction motor is always less than that of synchronous speed. Why? Because of the rotor conductors are short circuited. Then actual speed of the machine, N is equal to Ns into 1 minus S. Okay, then rotor frequency equation, Fr is equal to S into F. Okay, S is what? The slip of induction machine. Then F is the frequency of the supply. Okay, that also you can concentrate. Then I made this explanation. Okay, that is with respect to the problem, whatever I have shown. P is equal to 6, F is equal to 50 Hz. Then no load slip is 1%, full load slip is 3%. That is 0.01, 0.03. Then what happens? Synchronous speed is 1000 RPM. Okay, then no load speed is 990, full load speed is 970. Then at standstill, okay, the motor is not rotating, N is equal to 0. Then what is the slip? Slip is equal to 1. Rotor frequency Fr is equal to what? S into F. Okay, what is the frequency? 50 Hz. The same frequency will be present. Then full load rotor frequency is what? Fr is equal to S into F. The value of the slip is given at full load. That is 0.03. 0.03 into 50 is how much? 1.5 Hz. Always the rotor frequency is less than that of supply frequency. This is most important, which is to be asked for 8 to 10 marks. Anybody is having any doubt for this problem? Can ask.